Okay, so here's a quick little tutorial to explain why negative exponents aren't negative numbers and why anything to the 0 power is 1. So let me go back through some of these rules. We know that when you multiply numbers with exponents with the same base, you add the exponents. We know that when you take a number, a power to a power, you multiply the exponents. And we also know that if you divide numbers with the same base, exponent numbers with the same base, you subtract the exponents. So we have these three rules that we know about, so let's talk about them. So thus, a to the third times a to the ninth is going to be a to the 3 plus 9, which gives me a to the 12th. Agreed? Which means if I wrote a 3 times and wrote a to the third 3 times and wrote a to the ninth 9 times, I would be writing a multiplied 12 times, which is what our exponents mean. It means how many factors of that base number we have. So now if we take an exponent to an exponent, we take a power to a power, we multiply these guys, okay? So a to the 3 times 9 is going to be a to the 27th. And why is that? Because if I understand what exponents mean, this means 9 factors of a to the third. So if I wrote a to the third 9 times and then again broke those a to the thirds down to a times a times a, I would be writing 27 factors of a. And last, division. If I divide, I can write this division two ways. I can write it a to the third divided by a to the ninth, or I could write it as a fraction because we know that fractions mean division. So let's go and do this shortcut. A to the third divided by a to the ninth is a to the 3 minus 9, which turns out to be a negative exponent, a to the negative 6. But what does that really mean? Well, you already know that this actually means 1 over a to the 6th. But why? Why is it a fraction? Well, this is the reason why. If we can look at just a little tiny bit of proof, right? A to the third over a to the 9, this ninth is exactly what this means. We always can write division as a fraction. So it's a times a times a over a times a all the way to 9 factors. What can we do with these numbers because they're all multiplying? We can reduce them to a 1, right? Remember, we can find those ones. We're not canceling, we are simply simplifying. So what do we have left in the numerator? We have a 1 left in the numerator. And what do we have in the denominator? We have 6 factors of a in the denominator, which is another reason why a negative exponent is really just a number that's smaller than 1. Here's another bit of evidence. I know that a to the ninth is a to the third times a to the 6th. I know that because of this rule. Agreed? So if I break a to the ninth down to a to the third times a to the 6th, I can simplify a to the third over a to the third. And again, what am I doing when I'm simplifying? I'm trying to break things down into ones. So now I have 1 over a to the 6th. And this is why negative exponents are just fractions. They're numbers that are less than 1. So a couple of examples that we can do are a to the 4th times a to the negative 2. No, I'm sorry, to the negative 12. Sorry. So a to the 4th times a to the negative 12. If I do my shortcut, which is adding the exponents like I did up here, okay, I can say this is a to the 4 plus negative 12, which is a to the negative 8th. But I know that I have to write this as a positive exponent and write it as a fraction. Now let's look at why this is a to the 8, 1 over a to the 8th. Because this guy here is a to the 4th over 1. This guy here is 1 over a to the 12th. So I can simplify that to a to the 4th times a to the 8th, because 4 plus 8 equals 12. And there I go. There's my ones. can you kind of figure out already why anything to the 0 power is 1? Well, we can use this information. We know that dividing fractions, a to the 8th over a to the 8th, well, anything over itself is 1. So, what do we know about dividing numbers with exponents? As long as the base number is the same, we subtract the exponents, and look at what we get, a to the 0. So anytime, I'm sorry, this should be division. I'm sorry, I kind of messed up on that one. Let me do another one so I can be more clear. Okay, what about x to the 3rd divided by x to the 3rd? Well, the rule says that we subtract the exponents. So I'm going to get x to the 0. And we know that this equals 1. But why does it equal 1? Well, what is x to the 3rd divided by x to the 3rd? It's 1. Which is why x to the 0 power equals 1. And any number to the 0 power will equal 1. That is one way that we can prove negative exponents and 0 exponents. Another way we can prove them is by looking at scientific notation. But unfortunately, I told you that this would be a short tutorial, so I'm not going to look at this as scientific notation right now. Perhaps I'll make another tutorial.